Now we are going to learn how to solve for angles using the primary trigonometric ratios. To solve for the angle, you must use the inverse function, which is sine -1, and cos -1, and tan -1. And you will find that button on your calculator probably by hitting a second or a shift and then hitting the sine, cos, or tan button. So often you'll see it above the sine, cos, and tan button, that -1 symbol. Okay. So let's try this in a couple quick examples here. So solve for theta in the following examples. If you have sine of theta equals 0.4782, what we need to do is somehow get theta by itself, that unknown. Well, we need to undo sine. Well, how do you undo sine? Well, you have to do the opposite of whatever sine is doing. And so that's called the sine inverse. So this becomes theta equals sine -1.4782. Because when we inverse this, we get rid of the sine. Okay? So this crosses out that. Like adding undoes subtracting, or subtracting undoes adding, and multiplying undoes dividing, and dividing undoes multiplying. The inverse undoes the sine or the cos or the tan. Okay, if you type that into your calculator, second sine, and you do 0.4782, you'll get 28.6. Now remember that theta represents an angle, so we actually just found out the angle right there at theta is 28.6 degrees. Same thing here. We're going to undo tan by inversing it, so it'll become theta equals tan -1, 2.01. And we get 63.5 about degrees. Okay, so that's the approximate angle measurement at theta. We're not afraid of fractions here, so theta equals, and then we do cos -1, and this time it's 3/5 as the other side there. So cos, second cos, 3/5, and we get 53.1 degrees, approximately. So this is exciting because that means we can actually solve for an exact measure. So let's try this out with a triangle. So we're going to identify the angle that we are solving. Then we're going to identify two known sides. And then we're going to write the appropriate trig ratio using number 2. And we're going to solve. So let's identify the angle we're trying to solve. So we're trying to find here in this first example, angle B, theta. We're going to identify the two known sides. So we know this side and this side. So from B's perspective, 9 is called the opposite side, and 12.5, because it's across from the 90-degree angle, is called the hypotenuse. So remember SOHCAHTOA. And we're going to find the appropriate trig ratio that uses opposite and hypotenuse, and that, of course, is the sine trig ratio. So we write down sine theta equals opposite over hypotenuse, the definition of sine. So let's fill in what we know. So sine, we can call it B if you'd like. So sine of B equals, and the opposite side is 9, and the hypotenuse is 12.5. In order to solve for B, we're going to undo whatever is happening to B, and so we need to undo sine by doing the inverse. So B is equal to the inverse sine of 9/12.5. And so second sine, 9 divided by 12.5 is equal to, I'll put down an angle measure there, so angle B equals 46.1 degrees, to round to the nearest tenth. Okay, let's do that again with the second example here. So identify the angle you're solving. We're trying to find B again, so theta. This time we're given 11 and 9.4 as our two sides. 9.4 is called the opposite side, and 11 is called the adjacent side. So what trig ratio uses adjacent and opposite? Well, adjacent and opposite is part of the tan ratio. So we're going to write tan of theta equals opposite over adjacent. So tan, we'll fill in what we know. So theta we'll call b if you'd like. Opposite side is 9.4. And the adjacent side is 11. And to undo what is happening to b there, so we're tanning b, we're going to inverse tan. So we get b equals tan negative 1, 9.4 over 11. And we're solving for the angle there at angle b. And so we type that into our calculator. So tan negative 1, 9.4 divided by 11 is approximately 40.5 degrees. And there we go. We have the exact, we can find the exact angle measure there. And that's pretty powerful. Okay, let's go to one more example here. This one's actually from the homework. So in triangle DEF, we have angle E equals 90 degrees. So let me just draw some random triangle. I don't really know what it looks like. It's not my best triangle either. So here's angle E. It's 90 degrees. We have two other angles, so they're D and F. I'll badly guess at which one they are. So little d, remember, is across from big D. So this is 7.2 centimeters. And little f is across from big F. So that's 5.8 centimeters. Now it says solve the triangle. Well, solving means finding all three sides and all three angles. So let's just pick one angle we want to solve here. So let's try to solve for F. Okay, so I'll just stick it right there, looking across, and stick it, looks across and sees this side, the opposite, and beside it, it sees 7.2, so that's the adjacent. So we got tan of theta, because remember opposite and adjacent are tan. Sorry for not mentioning that earlier. So the trig ratio that uses opposite and adjacent is tan. So tan of theta equals opposite over adjacent. Fill in what we know. So tan of F equals opposite 5.8 over 7.2. To undo what tan is doing to F, we inverse it. So we'll bring tan to the other side by making it tan negative 1, 5.8 over 7.2, and we get we type that in to the calculator, and we get angle F equals 38.9 degrees. So we have 38.9 degrees right there. Well, if angle F is 38.9 degrees and angle E is 90 degrees, it's actually pretty easy to find angle D, because angle D, if you remember, the sum of the interior angles should add to 180. So angle D should equal 180 degrees minus 90 minus 38.9 degrees. So we subtract the other two angles. And we do 180 minus 90 minus 38.9. We get 51.1 degrees. So now we know angle D as well. Now, how could we find that third side? Well, if you have two sides and you're trying to find the third side in a right triangle, we know that we can use Pythagorean theorem. So let me remind you, Pythagorean theorem says that a squared plus b squared equals c squared. Or in other words, the two legs, if you square them and find their sum, will equal the hypotenuse. So we get 5.8 squared plus 7.2 squared equals, and I'm going to call this side E right there, right? A little e, so E squared. And we get 5.8 squared plus 7.2 squared is 85.48. And then if we square root that, we get e to equal approximately 9.2. So we get 9.2 centimeters right there. So notice that if we were given a right angle and two sides, we were able to find the other two angles and the third side. We can solve everything about this triangle.